Hello, hey, welcome back. So today, in today's video, we are just going to talk about some key terms and concepts in cloud computing. We are just going to summarize everything we know under cloud computing. Just go through some slides and hopefully help us understand the concept very well. So the first thing we'll be looking at is computing paradigms. So what is computing paradigms? So computing paradigms is just like the process of linking two or more computers together locally. So we are using a local area network as indicated over here. We are using a local area network to connect two or more computers together so that they can be able to process information, they can be able to process data, they can be able to compute together like they compute as one. You get it? Because it's a network, so they share everything among themselves. And let's talk about distributed computing. Distributed computing is under computing paradigms. The distributed computing is just basically whatever workload given to a computer, whatever workload given to a network, because we are talking about computing paradigms, and distributed computing is under computing paradigms. So in this case, this distributed computing will be also a network of computers. You see, it says it's defined as a type of computer where multiple computer systems work on a single problem. So multiple computers, they are working together on a single problem. So if you say, hey, what is 1 plus 1? I have about 6 computers in a network. So all these six computers, I'm sorry, all these 6 computers will all use their process together. Together we stand. We use their processes together to find the answer to the 1 plus 1, which is 2. Then we'll give it to you. So yeah, that's basically what distributed computing is. Now parallel computing is similar to distributed computing, but with parallel computing you do not need standalone computers, just like the way in distributed computing you need standalone computers so that you link them together and do compute together. In parallel computing, that is not the case. There can be one system unit, and in this system unit or in this server or whatever computing hardware, there will be a lot of processors. If processor is what is being required, there will be a lot of processors, more than one processors in this in this system unit. So it works together. The processors will work together. So the single hardware processors, which is in one server or one system unit, will work together to provide the answer to something. So the difference between the parallel and distributed computing is the parallel computing uses, in the case of the parallel computers, the components is talking about the individual components, a lot of individual components coming together to produce an answer or to compute a data or something. Whereas the distributed computing, this one, plenty computers, one computer, plenty that have been connected together, and then they are solving a problem to bring one solution. We all come together and solve one problem and bring one solution. Now what is cluster computing? Now with the cluster computing, all these computers, they work together to perform the given task or the task that they are expected to perform. So just like the way in distributed computing, there are lots of computers. That's the same way with cluster computing too. There are a lot of computers, and some may be referred to as nodes. So these computers work together as a single machine. You get it? Distributed computing, the problem is shared to them, but cluster computing, they work together as a single machine. So even if you have 10 system units, and then with cluster computing, they are identical systems. They work together as a single machine to compute a problem. And the reason this is done is just to improve performance and scalability. So for instance, you have two computers and you're processing data, a lot of data, and it gets to a point the data you're processing is too much, so the computer starts running slow. So what cluster computing will do is you have to look for the same type of computers you are using or system units or whatever you are using, and then add it to the cluster. Like you add it to the other ones, and then just you increase the number of computing computers you are using, the number of hardware you are using, so that the data will be processed faster because they will all work together as one. So if one gets false, even the one is false card, they'll still be working together. Hopefully, I do hope you understand what I'm trying to say. I really do. Okay, so that's it for computing paradigms. I mean, now let's go to cloud security. So with the cloud security, what is cloud security? There are practices and tools that are set aside. They are set there to just to secure the cloud and then prevent cyber attacks and things. You see, as day goes by, people are thinking. They are thinking of ways to attack companies or organizations. So you also have to put down systems that will handle these people when they try to attack your organization or however you want to put it, your company or whatever. So how does this work? They use antiviruses, they have security personnel, they have firewalls, and they are all there, and their purpose is just to prevent an unauthorized person from accessing your data in the cloud. Now I know you are saying, if all this is there, then why would I want to keep my information or use the cloud if it is not that secured and I'm at the risk of losing it because someone can hack it? Well, there are solutions to that problem. The solutions given to these problems are encryption. So with the encryption, if the cloud company is sending you your data, they'll encrypt your data and you have a decryption key. So when it gets to your end, you will see the data. So anyone who tries to hack it, the person cannot get the data because it is encrypted. The person does not have the decrypting key. So even though the person knows an information is being sent, the person cannot see what it is. So we are safe. The person cannot tamper with it as well. And then adoption of agnostic platforms and so on and so forth. Now let's go to the next system. So I'm wrapping up so that the video will be short. I don't want this video to be quite very long. Let's talk about cloud busting. Now let's talk about cloud busting. What is cloud busting? Cloud busting is an application deployment technique. You see, cloud busting is all about scalability. Let me just put it that way. It's all about scalability. Assuming I created a website and I decided to run the website on my laptop. You see, so I'm running the website on only my laptop, and then as time goes on, the website becomes famous. It becomes famous. People will start saying, hey, wow, this website, like the organization or the company was like they really done well, they are doing a good job and things. But meanwhile, they don't know I'm not a company, I'm just running it on my laptop. So what do I have to do? My laptop is running slow because the demands coming to the laptop is so much. A lot of people are opening the site, so there are a lot of requests is hitting my laptop and it's making the website run slow, and I'm running out of storage and things. So what do I have to do? I have to scale up. I have to provide myself with more laptops to in order to make the website respond faster. So this process where you go from a private cloud to the public cloud because your demand is increasing is what is known as cloud busting. So it's like you have passed out of the private cloud into the public cloud because the demand is too much and you have to scale up. And then the public cloud is huge. So if you go there, you have access to the resources, enough resources. You don't have to think about slowing down and other things. So that's just basically what cloud busting is about. If you are asked about the advantages and disadvantages, just wrap your head around these things and around these concepts and think about how it can benefit you and how it cannot benefit you, and you'll be able to provide all the answers to it. So it's nothing really difficult. Now let's go to the next slide. The next slide is on cloud deployment. What is, I know you are wondering, what is cloud deployment? Cloud deployment. I know the, like, look at the words of deployment. It's like you are deploying, you are putting it out for everyone to access it. So cloud deployment is just the process of like enabling service models. Service models, it could be software as a service, platform as a service, or infrastructure as a service. Just putting all these services available, putting it on the cloud so that every user can have access to it. So you deploy it on, all hosting models so that everyone can, wherever everyone is, it can be able to access it. So that's what cloud deployment is all about. There's public cloud deployment, there's public deployment, there's private. Public is you launching it into the public cloud, whereas private, the public deployment is, as the name suggests, supports all users wherever you are. Everyone can have access to it. That's basically what the public cloud is, whereas a private cloud is just to an organization. So before you can have access to it, you have to be an authorized. You have to be an authorized user before you can have access to it, and you have to be granted access to it before you can have access to it. That's basically what the cloud deployment is all about. Now, when we talk about a hybrid cloud deployment, the hybrid cloud deployment, they both use the private and the public cloud infrastructure. They scale up. You see, as I was saying in the other slides, when you are running your application on a single laptop and you are having problems, you need to scale up. You need to increase your hardware. You need to go up so that you can handle more requests. You can, so that your website or whatever you are doing doesn't become slow. That's the same with the hybrid cloud deployment. Sometimes you deploy your website or you deploy your project on a private cloud, and you realize that I have to go up, because if I go up, I'll make a lot of money, I'll get a lot of users, and already people are already asking them. A lot of people are asking for it, and where I cannot save all these requests. So what do I have to do? I have to go to the public cloud. So in this case, you have used both the private and then the public cloud. So it is referred to as what? The hybrid cloud. That's all it is. It's not that difficult. Now let's go. Let's talk about let's see what is here. Okay, so that brings us to the end of this video. I know we didn't talk about quite a number of slides, but those slides are very easy. What is cloud computing? I know you are. Cloud computing is just you providing computer resources as as a service to someone over the internet or over a network. And another thing is virtualization. I don't know, I think I don't have the slides. So virtualization is just basically running. There are types of virtualization, you see. So virtualization is you running, let me see if I can pull up the slides. I do not have it. Virtualization is you running either an operating system without actually having the operating system installed on your system. So it's like you are running an instance of an operating system on your system, and this is a file. In this case, this is a file. Let me show you an example. I'm using a virtual system right now, a virtual operating system. This is Ubuntu, and this is a virtual operating system. That's what I'm using right now. So if you come, I'm minimizing it. So this is my computer. My laptop runs on about 4 operating systems. Yeah. So this is my hypervisor. A hypervisor is a software which runs on the hardware itself and allows you to run the operating system. If you are working with an operating system, it allows you to run the operating system on your hardware, even if you don't have the specifications required to run the operating system on your hardware. It will allow you to run it. So you run an instance of it. So you don't have to install the operating system on your laptop before you can run it. You only need an instance, which in this case is a file. When I open this file, you can see I have Kali Linux and Ubuntu. What we're using, what you saw, this is Ubuntu. This is what you saw. This is the file. This is what I'm running. Here is it. So this is the file I'm running. So if I'm running this on a file, if I'm running it on a server, and the server goes off or something happens, this is what is being transferred to another server for me to continue, working, and so that I wouldn't get distracted on the cloud. So this is what virtualization is. There are types of virtualization. There can be application virtualization, hardware virtualization, operating system virtualization, and so on and so forth. So it's just, it allows you to run uh, resources. It allows you to run resources on your laptop, even if you don't have the hardware requirements to run the actual resources. It gives you instances. So you run the operating system or whatever you are trying to run your application on a computer somewhere, but you'll be running it on your computer, but you are running it, actually technically you're running it on a computer. You're only seeing what you are running on the computer. I hope you get what I'm saying. That is what basically virtualization is. This is an example, so hopefully you understand. You can see I have WhatsApp, so it's like I wouldn't even know if I don't tell you I'm using and if I don't tell you I'm using a virtual operating system, you wouldn't know, because see, look, it's beautiful, it's nice work done. So that's just what virtualization is about. Yeah, so that brings us to the end of this video. I know it has been a little, should I is that a bot? Whatever. It has been a little summary, but next time we'll try and make it better. Alright, thank you for joining and see you in another video. Have a good night.